Oops, sorry. Okay, ladies and gentlemen, I think we will start, so please take your seats, and if the doors could be closed. Good morning. After the gala dinner, it seems that it was too much burden to take, so some of us are still tired out of it. Thank for the organizers. Good morning to the session 8A on information retrieval. I'm happy to be here sitting among the people who really do have something to say about what's going on with the web and the ongoing task of driving it to the full potential, as the W3C uses to say. And we will hear something about the ongoing tasks and results challenging, I would say, not the problems that we are confronted with, especially in the area of metadata and searching environments and semantic web. So, without a further delay, as we are delayed with the start, I would like to introduce our first speaker, Mr. Max Dekkers, who is now working for Dublin Core Metadata Initiative, where he is the managing director. He has been with the DCMI for a while as a chair and a member of advisory committee, working with the information technology standards and all this stuff since early 80s, so he has a career of dealing with the metadata issues, and he will talk with us about the metadata, Dublin Core Metadata Initiative, its current status and future developments. Max, please.
Thank you. How can I get my slides on here?
Yeah.
Well, welcome to this morning's program. Thanks to the organization for inviting me to talk to you a little bit about the work that we do, the Dublin Core Metadata Initiative, in trying to build a core metadata set for the internet and helping also to realize the vision of the semantic web in a way. Let me first tell you something about the organization. I guess that most of you have come across the organization and what it does, but still like to give you some context, tell us what we try to achieve, and tell you a little bit about what we're doing at the moment and where we are thinking of heading in the next year. The first thing is Dublin Core Metadata Initiative is an organization that really doesn't exist. It exists in an informal sense. I call it a virtual organization because people all around the world contribute to it, but there is no, I would say, real head office of the organization. We're not incorporated anywhere. Currently, we're hosted by OCLC, the Online Computer Library Center in Dublin, Ohio, one of the major library services hosts, who takes care of the personnel, the small staff that is involved in the initiative. It hosts a website, and it also funds some travel for participants. Other funding that we have comes through external sources, the European Commission, for example, the National Science Foundation, national programs in various countries. And the work is also distributed. We work with people who are actually mostly volunteers who do work for the Dublin Core Metadata Initiative as part of their own job, as part of their own research, as part of their own job description, and they are located everywhere on the world. What are we trying to achieve? Well, it's quite simple. We try to achieve a metadata standard, a core metadata standard that is going to be used for discovery across domains. That was the original vision that led to the establishment of this group of people in 1995, discovery in a cross-domain environment. To do that, we have always been interested in defining frameworks, how metadata, various metadata standards can work together, because we see, I think it's fair to say that no single metadata standard can satisfy all requirements. So we see the need to work together with other metadata standards that may be more specific, or maybe more elaborate. And what we also try to do is we try to facilitate the community building, either in general or in specific disciplines, to work on the first 2 points of our mission statement. So to meet that mission statement, we engage in a couple of different activities. We develop a standard. It's a simple standard, but at least any standard, I think, and it's many of you will know, needs maintenance and needs development. We also support development of tools. We give links to tools. We have groups that would discuss the development of tools. We have meetings sometimes between tools developers. We also have, of course, a number of services that are run using the Dublin core. We try to bring those together and get them to see how interoperability can be achieved. We try to do educational outreach in the sense that we think that with this work that we're doing, we could benefit lots of people around the world, so we try to also bring that to their attention. And we liaise with various other communities, like the educational community, like the industrial communities. Just a quick overview, probably for many of you already familiar, or at least you should have heard about it. The Dublin Core Metadata Standard is an element set, so properties in some terminologies, that you could, things that you could say about resources. We're looking at web resources. We started out from a perspective of document-like objects, but in fact these 15 elements are considered to be sort of a general level of description of many types of resources. So you would have the things that say something about the resource in terms of who produced it, what the title is, what kind of subject it has, what format it's in. So a very basic set of 15 elements where many resources in many domains can, at least on a high level, be described. As I said earlier, we know that with such a simple set you can't meet all requirements. So what we also did within the framework of the Dublin Core, we provided a mechanism to make more specific assertions about resources under these 15 headings. So we invented a mechanism that we call qualification, where you can say things, for example, that the date is actually the date that the resource was created, or that the relation of this resource to another resource is that this resource is a part of another resource. So if another level, but still very simple, to make some more precise assertions. And then we provide the possibility for people to extend the metadata element set, both in terms of what we call top-level properties that they would need for their own use. We have one, the audience element, which says for whom this resource is intended, that has found application in 3 domains already at the moment that we know of, in education, in libraries, and in the government area. And also you can extend the metadata element set with qualifiers to qualify either the existing ones or the new ones. Then again, there is also the possibility that you define local extensions that you don't want to submit for global standardization, but that you still think are useful in your own environment, and the standard also allows for that. With the work that we've done over the last couple of years, we have now created 3 namespaces. We have the 15 elements, which for historical reasons are called version 1.1, DC 1.1, and you see the URI for the namespace there. Everything else that we do that is added later will be in the terms namespace. And then we have also a number of controlled vocabularies that we needed for describing things. For example, the type of a resource is a list, a small list of terms that we also maintain. and we could see that in the future we may need more of those lists, and we will create namespaces for them as well. A little bit back to the organization as such. As I said, we are a distributed organization around the world. We have the directorate distributed over the United States and Europe, in Luxembourg, where I live. We have a board of trustees, which is a group of 9 people from various domains on a high level that give us advice on strategic issues. Then we have an advisory board, which is a collection of experts, many of them from technical domains. For example, Dave Becket here is a member of that board, as I'm, and also the W3C is represented there. Then we have a usage board, which is a group of people that looks at the semantics of what we're doing to make sure that if there's elements that are added to the standard, if there are descriptions that are made, that actually fits with the model that we have and that there is no conflicts with other elements. A board of trustees that oversees and gives strategic advice, and you can see they're from various domains. We have people from the educational domain, from the libraries domain, some large international organizations, industry, and the university environment. And those people advise us on the way that we can develop the standard and the organization in the future. The work is actually done from everywhere in the world, and we have a community at the moment of about 1,500 practitioners, people who actually use the standard, who want to use the standard, who develop services and tools, and they represent around 1,000 organizations in 50 countries, in I think all the continents of the world apart from the Antarctic. We have 17 active working groups and interest groups, and on our website you can see links to the work that is being done and to the information, the documents that are being produced. Out of the 1,500 people that are involved in one way or another, mostly from subscribing to the mailing list and coming to our annual conference, we have around 75 active participants in these working groups, which you can see as being the chairs who lead discussions, authors and editors, and also reviewers of documents that other people are producing. Various domains are represented, libraries, digital libraries, projects and organizations, educational services, I would say, distance learning, things like that. E-government services is a group of, is a domain that is becoming much stronger in the last couple of years. And also the business domain is represented in our participants. Recent news, actually last year the Dublin Core version 1.1 was agreed as an US national standard. I have to tell you that in Europe it was in the early months of 2000 that a CEN workshop agreement of the Dublin Core was agreed, although that doesn't have the same formal standard status as a standard in the United States. We have a number of governments that have now officially adopted the Dublin Core as a standard for description of their electronic resources. And this list of 7, Australia, Canada, Denmark, Finland, Ireland, New Zealand and the UK, is a start. Many other countries are at the moment in the process of looking at the Dublin Core as a standard for their government information. In Europe, in the middle of last year, a number of e-government programs came together in Brussels for a meeting to see how what they were doing on a national level would need to interoperate on a European level. And that has led to an activity that is funded by the European Commission to build a EU metadata framework, and we hope that will be available in this summer. Various large implementations that we've seen developing over the last couple of years is one of the major ones, I think, the most extensive ones, is the Open Archives initiative. I guess you have heard of that. We also do see implementations for internal knowledge management in large international corporations. There are several of them that already use Dublin Core or something that is very closely based on Dublin Core, and there are many more that are currently asking us for some advice on how to do that across their country establishment, across their various departments. The same is true for large international organizations. For example, the United Nations, various parts of the United Nations are also doing their internal information transfer between their various offices in the countries in the world on the basis of Dublin Core metadata and use it there as an exchange format. And as I said, many digital libraries projects in the US, in Europe, and in Asia are basing their work on the Dublin Core. And also there is a development of open source tools, but also commercial tools that support Dublin Core metadata. At the moment we're working at building a set of guidelines of how to express the Dublin Core metadata element set in practical terms. What we are doing mostly within the organization is talking about the semantics. What do you try to say? How do these properties hang together? But of course, when you start doing a project, you're implementing that in a certain encoding. And we're working on the guidelines. We have guidelines on how to do it in HTML. We are hoping to publish very soon the RDF guidelines, and we're also developing the XML guidelines for implementing the Dublin Core in the next couple of months. A number of groups in the Dublin Core Metadata Initiative are working from a domain perspective. For example, the e-government people have a working group, the educational people, the library people, and they work at looking at how can they use the Dublin Core for their specific domain. What kind of additions do they need? What kind of extensions do they need? What kind of relations do they need to have with other standards in their domain? And one of the things that those groups are looking at is building application profiles, in the sense that you declare what you use from the Dublin Core and how you use it, and what you use from other standards, and how these things fit together as a package for your specific domain. One of the things that we see is necessary also is a way of publishing our metadata element set in a registry. There are many registry activities going on to do similar things. In fact, what we say is what we are providing is basically the dictionary to our terms. And that is something that is under development at the moment. A number of other groups that are working are people who are looking at how do you provide citations to journal articles, for example. There are people who are looking at how do you describe people and organizations rather than electronic resources. And also there is a group in the UK that works on the collections. How do you describe collections of resources to various levels of granularity? And the support for development of tools, both open source and commercial, is one of the things that for us is important at the moment. We have a couple of challenges that we see for our work in the near future. One of the things is that we, as I said earlier, are not an incorporated organization, so we don't exist. We are dependent on external funding, which is not always very solid. And that is something that we're looking at in building a sustainable organization, at least a small organization that can do the things that we feel are necessary to do. We're building slowly links to the commercial sector in the area of the knowledge management developers, the products and technology developers for knowledge management, and we hope to in this year get some strong ties to that community. Official standardization, especially when you work with organizations like governments, being able to point to a official and registered standard, I think is important, and we are now working with people in the International Standardization Organization to move the Dublin core into the ISO standardization process, and that may of course take a while to get that through. And we are also building these ties with other groups to look at interoperability of the Dublin core with other standards, and there is already work on their way there.
Time, please. Time.
Okay. Just. We do cooperation for cross-standard interoperability. I say we have a common principle document that we developed with the Learning Object Metadata group in IEEE, and we're working in a European project to bring together a number of standardization activities to discuss issues of longer-term interoperability. And we are also talking to a number of parties to look at registry interoperability. Finally, I would want to invite you to look at our next conference. We have one conference every year. This year will be in Florence in Italy in October, where we will have tutorials, a conference and workshops where our working groups meet. We have a call for paper out, which closes next week, and we will have a preliminary program by next month. Topics that we will cover in our conference are linked to what I just said, domain-specific work, search engine usage of the metadata and Dublin core metadata, knowledge management, commerce and intranets, the indexing, relation to indexing and ontologies, and tools for metadata interoperability. So finally, what we will be doing in the next year or so is we will further develop our specifications, also look more closely at guidance materials and best practice materials, extend our network of global implementers, and we are starting good relationship with people in Southeast Asia, for example, that are very much interested to cooperate. Cooperation with other metadata standards worldwide to keep that whole conglomerate of metadata standards at least moving in the same direction, and we feel that that would be a contribution that we can make to the semantic web and knowledge technologies. So here is our website if you want to have a look at what we're doing, and I will be available for questions during the rest of the morning. Thank you.
Thank you very much. We are a little bit late, but I think that we have time for one question if somebody has a question. On the other hand, Makx will be available during the coffee break have a coffee with the speaker, not have a lunch with the speaker. Okay, we will postpone the questions for the end of the session. Now, our next speaker is Dave Becket, who is a technical researcher at the Institute for Learning and Research Technology at the University of Bristol, UK, and Dave has been working also with the Dublin core and RDF. He is a participant in RDF standardization work at the W3C consortium and as a part of the W3C Semantic Web activity. They will speak about the web search environment. It's a fine example of combining existing technologies, web crawling and metadata RDF format and Dublin core standard to put together a promising service. So, Dave, please.
Thank you. Thank you for inviting me. Don't worry about writing down the URL. I'll get to that later again. So, just while I remember what Makx was just saying, I should relate to what I'm doing with that. In particular, I've been working on some of the metadata registry things for educational metadata and Dublin core for representing that, and also with Dublin core for descriptions of collections. It's not actually in this talk, but it's just something else related. So I work at the University of Bristol in the UK at the Institute for Learning and Research Technology, and we cover a wide range of interests. We're a research unit, and as well as that, we also run services, mostly in the digital library area, and most of those services are based on Dublin core technology, metadata systems, cataloging systems. I'll get to those in more detail later. So we go all the way from research into deployment of real services for the higher education, further education, teaching and learning community. And we also do research onto educational issues, pedagogical issues. So what I'm going to cover in this talk is a project called Web Search Environments, which is covers a sort of a spot between two different things, web crawling and these things, subject gateways. So I'll go over the overview of what those things are. I'll talk about why this project came about, what particular is new about it, and what the sort of results are that were novel. And then after that, I'll go into sort of future work from it. So what is a digital library? And I'm talking about the digital library community in the UK here. The digital library in the UK, we talk about subject gateways. I'm abbreviating it on the slide to SGs for space. Subject gateways or subject portals or subject hubs, ways of accessing a particular subject strand. So it's a vertical description, a vertical service. So, for example, there are ones on social sciences, engineering, history, and so on, with all these different names. So these things are operated professionally by experts in the field and professional librarians who understand the world of their subject. So these things exist, and as always, they want to improve them in various ways. So they want to improve the scope of the things that they're cataloging. The things they're cataloging are mostly web resources, websites, and maybe mailing lists and other things that are available. And they want to be able to do more of this, as obviously the web is growing all the time. However, this stuff has to be kept up to date, so it's always important to make sure that the resources you've got available are fresh. You want to be able to keep it fresher and better all the time. And also the cost. Making people catalog the web is kind of expensive. And if you want to do all this, again, you'd quite like to be able to do it cheaper, as always. However, all this has to be done with the goal of remaining professional. You don't want a sort of a lowering of the quality of the description and the kind of resources that are catalogued. There's no point just doing that. You could go out to some random web page to do that. And the big killer, of course, is you've got to compete. This kind of thing has got to be able to work and compete with the professional things like a search engine, which I call the Google test here. If it doesn't work, if it's not better than Google, nobody will use it. So human cataloging of the web has got these sort of issues. We do get a high-quality service. We have the domain-specific knowledge and selection. We've got the cataloging done to well-known and developed standards, such as the large standards like MARC, which is about this much shelf space in terms of cataloging description, and all the very much detail. Of course, the cons I've gone through roughly are it's expensive because you're paying people to do it. It takes several hours, if not longer, to catalog an individual resource, because these things are quite detailed records and take a lot of description, as well as actually refining them. So expensive and slow, and these descriptions need to be reviewed regularly to make them relevant. The web changes, not only grows, but the original sites that are catalogued change, so these have to be reviewed now and again to keep the descriptions up to date. So the other kind of system I mentioned briefly was a web crawler like Google, and these things run on their own. Now, the pros for that, of course, it's vastly comprehensive. I forget how much Google claim to index at the moment, but it's a very large number. The con, of course, of that is it's far too comprehensive. There's too many answers for some things, and but again, it can be very up to date because the software doesn't sleep, and you can always throw more computing power or networking at it. However, this stuff is not a human. It can't distinguish pages or links that it goes around the web, which say that the page that you're pointing to is a really bad one or a really good one. They're looking at the link text, the words that are actually on the link, and using those to index the page that it's pointing to. And unless it became something that started understanding all human language, or some human languages, it's going to be difficult to distinguish that from a site that rules, a site that sucks, or whatever, those kind of words. And it's indiscriminate and is also subject to spamming, which is where keywords are deliberately put in the web page to confuse the system, so the description isn't true. And these are the kind of things that, of course, humans reading it would understand properly, whether it was the quality level of the site and whether it was really correct. So this is where the WSE project came in. We tried to combine web crawling and high-quality description. We start off with the web crawl from the high-quality records that we've got available from these subject gateways. We crawl to other presumably good web pages, because if they start with a good page, they're presumably also a good link to other good pages. That's the theory. And as we do that, we track the provenance. That means we track where in the web crawl is, where we came from, and why is that page pointed to, who said it was good originally. And this stuff we could use later on. So this became the project, and it's researched by ILRT itself, funded by some of our subject gateway projects, and the Resource Discovery Network, which is a UK organization which runs a lot of subject gateways and also manages, in the larger sense, the national portal for accessing subject resources. It's funded by the JISC in the UK. The RDN funds the gateways. We also had, as they are on the ILRT side, we actually got the Dutch, forget the actual acronym, it's a social science gateway. They also participated in this. So what technologies we've got? Very simple Dublin core records. I'll show you how simple in a second, that we take from the subject gateways. We use the OAI protocol to gather these records into one place. So that's just a sort of a harvesting operation. We use the Combine web crawler, which came out of the Desire project, which is a resource discovery project, which ILRT was part of a few years ago. That's just a bare web crawler. And we use the RDF framework, which we'll be going into in a little bit of detail here, to connect these descriptions together. So I said it's really simple records. Makx showed the 15 elements, and we're only using 4 of them. We get the title and the description. These are the human catalogue record title and description, so they actually make sense. If you go to a random web page, a search result, you get words scattered out around from the web page itself, which match the things that you were looking for. But here you'd actually get proper descriptions of the web page and says, this is a high-quality page about social policy or something like that, and goes on to describe why it's good and what the key aspects of it are. So it's a fully written description, of course, very good for indexing. We get the identifier, which is of the URI of the resource itself. So that's the web page that you actually want to go to. And we also take the identifier of the record. So the record I'm talking about here is the record that the subject gateway provided. So whenever you get one of these things, you can always go to the higher quality record that exists on the subject gateway site. Here we've got a 4-field metadata record. The records on the subject gateway site might have 20, 30, or even more fields that fully describe the original resource. And whenever you get to that record, you can generally navigate around that site and use their more powerful search. If you've got a specific site on some, I don't know, arts and humanities database, you could actually search around using specialized terms in that area once you've been directed to it via one of these records. And as well as searching, you can also browse around their hierarchy of structured indexing. Generally, there's a hierarchical approach to getting the results as well. So the model is here. We take the Dublin core records that describe all these resources. The web crawler reads those and returns web pages. And these web pages, in turn, generate a new resource. This is just straightforward web crawling. The provenance tracking part is to link back to the original records. So having got a new record which describes a web page, we point that back to where we came from, and we point back to where we came from in terms of the web page, and we also point back to the original record that described it. For this, we use the RDF model, as I mentioned earlier. So we connect these together by using the URIs, the identifiers. Each of the things that I've talked about so far is given an identifier. So the records that are described on the subject gateway service have identifiers like this. The things that we catalog from the web are also given a URI, and also the web pages themselves obviously have identifiers on the web. So all of these things have identifiers that can be used to connect and point things together. And this is the RDF model, connecting these things together. I don't think I said RDF was Resource Description Framework. This is the kind of thing that RDF is about. Resources are the things we're talking about here, and the simple Dublin core elements are the properties. So resource and description, we're describing the resources, and it's a framework because Dublin core provides the vocabulary we're using here. So on this graph, let's see if this laser pointer works. Right. So on this picture is just a simple example of where the web crawling is working. So we have on the left-hand side in the square boxes the subject gateway records, which have those 4 fields I originally pointed at. We do an initial web crawl and get the first 3 pages on the left. The circles are the web pages, so we get the first 3 web pages, A, B, and C. And then we proceed to follow the web crawl around again and get further pages. So page A goes to D and E, and so on. B goes to E as well. So we get a web of links created from the web crawl, and that is represented in the model of the system that we generate. So some of this is stuff that's grabbed off the web, and some of it is the high-quality information that we've got from the original subject gateway catalogs. Now, it's obvious that some of these things are not rocket science. Metadata gathering is not new. This kind of stuff has been around for a while. There's a project called Harvest, which did this kind of thing, I don't know, 94? It was very early on. Web crawling is also not new. Lycos was one of the original web crawlers. It's also been around for ages. So there's nothing new there, really. And cataloging, obviously, is not new. People have been doing that for thousands of years. So what exactly is the new thing that we're doing here that makes this different from just the components that construct it? Before I go into that, I'll just digress into what's not so crucial in this project, and we didn't optimize for that because this is also stuff that could be investigated. Gathering data together, I mentioned that we were using OAI to gather together to do the web crawl. It was not important to do that. The combined system is a distributed web crawler, and we could have crawled that in parallel. So that's not the crucial thing. The indexing of the content that we get back is using a standard off-the-shelf full-text indexer. We didn't spend much time concentrating on optimizing that for the job in hand. There's only 4 fields, or even only 2 or 3 that are being indexed. A standard off-the-shelf one would do it. And the web crawling algorithm, there's plenty of research on the ways that you select routes through the web. We didn't spend a lot of time optimizing that because of the focus was on trying to connect these things together. So we didn't do that in a sophisticated way. So what are the benefits? Well, the existing subject gateways that we've got in the UK, for example, all have their own search services, and obviously you can search the records there and get back the results from the records. But that's generally not good enough, so you want to generally go to a higher level, and you get these things called cross-searches. A cross-search is where you search all of the subject gateways in parallel, so you send the same query to all of them, and you get back the results. That tends to be rather fragile because it relies on all the services being up at the same time and responding within half a second so you can take all the results and do something. It also tends to present the results in a rather sort of striped fashion. You get the results from all the subject gateways in turn coming up the screen. If you've ever seen a crawler, there's a crawler equivalent that's generally called meta-crawlers, and they have problems merging the results as well. So the benefit of this is that you get all the results connected up in one place. And in particular, you get the record results and the web crawl results all ranked in the same way. There's no distinguishing these things. There's no sort of a group of higher quality and web crawling records split up. We're all mixed in. The relevance ranking is done by the text indexer. So the general benefits from that, as well as that we also get to do with the general power of the RDF model. As I said, everything can be linking into anything else. And you can also pour more data into this because this system is not optimized for, is not restricted to a particular schema, a particular set of terms. Because of the model of using the URIs for all the descriptions, we're using Dublin core elements here, but we could throw in any kind of other system metadata we like. If we had a description from the educational standards, such as the IEEE LOM or something to do with relations, some other sort of descriptive information about that describes websites, such as, I don't know, picks quality ratings or privacy ratings or something, you could pour that information into this, and the system would just add the extra relationships. So we're talking about those kind of things, and we've also got the leveraging of existing systems and standards. We're using off-the-shelf technologies here for on the web and existing software solutions for those, and we're connecting them together. So the novel bit, what does this do that you can't do before? I mentioned previously that what you would have typically, or actually what you do have now in these kind of systems, are individual searches on the subject gateways and cross searches. And if you search for something like this, you may have game theory. You may have heard of game theory is a term which is used in economics and other areas. It's a kind of an approach for modeling choices. And Napster is a technology which, ironically, has got banned since I wrote these slides originally. What on earth would you want to do if you searched for both of those? Why would you want to combine those? Well, it turns out that there's a quite interesting paper about game theory to do with Napster on the web. Now, if you looked for these terms on a subject gateway, you would get 0 hits, because the catalogers have no term for Napster. Not surprisingly, it hasn't entered the cataloging standards, and it wasn't in the description. And secondly, it was also not catalogued because at the time that they wrote the description, the web page that had this link wasn't written. So it was to do with the timeliness. So if you do that search on the WSE searches, you get back the result. And the reason why you get back the result is because it looked at the web page afterwards. Now, the reason why it looked at the web page was because it was catalogued previously. So WSE gained on that because you got the high-quality resource which the catalogers had given it, but it added the freshness, the new words, the terminology that came along later after the cataloger. The cataloging records, I said, are generally meant to be reviewed regularly, but as it turns out, in all human things, they don't review them as regularly as they would like. So you gain from that. You also get 0 hits on the cross-searching for the same reasons. These words do not appear in the records when you do a cross-search. So all of that together, and also cross-subject searching in one system. For example, if you search for GMO, you get hits from a whole bunch of, this is GMO, genetically modified organisms, is a sort of a hot topic. And you get hits from a whole bunch of things that you would expect to get hits on, sort of the social side of it, the political, the scientific. And you also get some of the sort of related wacky terms. For example, I think you get a hit from something called the Natural Law Party, which is a political party in the UK and Europe, which has a policy on genetically modified organisms. And it was linked because it came under the politics section of one of these sites, and then the web pages related to that came up. So you get a full view of the sort of area. If you went doing one of these kind of searches on Google for GMO, or you'll end up with a zillion hits because everyone's got an opinion. You'll get the randomest web page about genetically modified organisms, maybe. Here, you're assured you're going to get a selection of quality results as well as related things in the area. You get a high-quality sort of answer from that. I should have mentioned about game theory and Napster. If you do that search on Google as well, you also get 1 million hits, or lots, because the word Napster is talked about a lot. So you get those things that Google can't do, and things that the subject gateway searches can't do. And you also get the option of navigating the provenance. I said previously that the results just appear in a list, and if you look at the search online, it just looks like a standard web search. But it does let you follow the provenance back to see why is that a good page, why was that particular page on GMO, why did it come up, and why is it good? And you can follow the links back to the original site that catalogued it. You can see why they linked to it. You can see the original description. You can then maybe even go to the subject gateway itself and browse around that subject. If the web page wasn't quite what you wanted, or you wanted a more expansive answer, you've got to route back into the greater description. So the web crawling gains from the higher quality human description, as I described. The subject gateways gain from the more relevant pages, as I explained, things that happen post-cataloging. You also get much fresher content than human catalogers can keep up with. And in general, you get a much more focused thing than focused service than a general search engine because of this restriction to higher quality. I mean, the quality is a word you can debate about, but at least you can ask what the quality standards are here, because you can go to the subject gateway sites and read their cataloging practices and tell you why and how they choose the resources. And so there's a justification here which has been thought about seriously by professionals about why is that result turning up. So we've got this tool, and as the kind of audience it's aimed for, it could be used for the community of the higher education, teaching and learning, people who actually want to find things about the subject. It can also be used by the subject experts as well in a certain vertical community. And it also includes the catalogers, because that's the first stage of their work of cataloging this kind of stuff, is to go and find it. And this is a tool which gives them results which are related to the things they've already got. If they find something in the top 5 results which doesn't appear in a record, they might consider it as something worthy of cataloging. I contend without any formal analysis that it gives a good result. So that's just from my opinion. But it seems it's also very fast from the technology aspect of it. So new things that it also seems to indicate that I thought were kind of useful were these things. Cross-subject searching is possible in other systems, but this allows you to search subjects that have not yet been catalogued. I said about these portals tending to be rather vertical, so if you have something that falls in between the gaps of what they catalogue, you tend to get pointers to this if they're from both of these sort of sites, and you could actually have those pages appear as well. So you gain from the sort of from whenever the thing you're looking for falls between two sort of cataloguing chairs, or whatever the metaphor is, falls between two blobs. So you can also search things that are ahead of cataloguing standards. I mentioned that generally there's hierarchies and terms and words that you pick from them whenever you catalogue these pages. This allows you to gain and use things that are not actually in those areas. And of course it actually helps indicate where changes to cataloguing standards are needed. A thesauri are the kind of terms that they use to describe these resources. So this stuff was worked as a research project and is actually being deployed now. The ILRT have one. These slides, if you can click on the links and you can follow them from the slides later, are live. The RDN, the Resource Discovery Network in the UK, is going to use this, as I understand it, to replace their search for all their subject gateways at the top level. So this stuff will be deploying. It's a real research project based on Dublin core technology. Very, very simple idea. And the RDF model in just a directed graph. And this stuff is actually going to be used for a national research education service in the UK as the main search system. This is their resource finder, as they call it. So for subject gateways, what does this gain for them individually? As well as talked about why you'd want to use it on the higher level, individual subject gateways are also considering using this. Because when you're cataloguing sites, it's not possible to, what you have a problem with is that there are sometimes just too many things to catalogue. So you could actually set this tool out to do a deep crawl, as they say, take the whole part of a high-quality website and actually get the software to do the cataloguing or to do most of the hard work. And the other issue is to do with granularity of cataloguing that comes up. Catalogers tend to catalogue the web page itself. They have the thing. The catalogers take the thing in hand and describe that. But what they would rather like to do mostly is describe larger resources, big sets of web pages. And so, if that was indicatable in the description, then the software could be used to fill in the gaps, to let the catalogers work at a higher level and let the software fill in the bits and pieces that were sort of lower down, do the individual pages. So the kind of things that we're talking about here are the novel aspects of linking these things together. I didn't go into proving and targeting the crawling, but there's plenty of work that could be done there, because having got a page back, you can use the number of incoming links, the sort of quality distance metrics. You've got more than just you have when you have a web crawl, which whenever there's web crawling going on, there are ways of calculating distance and so on. But this one, you could have some sort of quality distance. You could even actually have web pages of intermediate quality. If you have these sort of high-quality records, you could have the ones that have been taken by the software, and you could have ones that were, like I was saying about cataloging groups of pages, you could have ones that were indicated by the cataloger as being of high quality, but weren't actually actually individually catalogued. So this stuff, you could use this subject gateway information to rank the results. At the moment, it's just using the kind of standard off-the-shelf cataloging of indexing of the terms in the web page and in the subject gateway records. And you could add other relevant data into the mix, and that would then appear in the results like anything else where it was relevant. So you could take in some of these RSS news feeds. This is a syndication format for passing around what's new and new content. Some of these services have these kind of things you could import into this system, and then as well as the web crawl results and the high quality results, you could get news items. So all of this, which I haven't gone into detail, is a semantic web application, and which nicely leads into what Charles is talking about next. But that's the WSE project. Thank you very much.
Thank you, Dave. It was an interesting work. If you have any questions, we can now ask a question. Just please go to the mic, and we have time for 1 or 2 questions.
So are you going to be distributing software based on this?
Oh, I should have said it's open source. Sure. Okay. The links will be off that web page URL there, but it's all free. Okay. Thank you.
Okay, thank you again. Our next speaker is Mr. Charles McCathieNevile, representing W3C Europe, but he's actually from Australia. His talk is update on W3C technologies, especially in semantic web and web services. And to introduce Charles, he's a member of Web Accessibility Initiative domain at W3C, editing the authoring tool accessibility guidelines, and actually works on full set of Web Accessibility Initiative guidelines. And he's also, of course, working with the review on W3C specifications for accessibility. Without further delay, because we are late in time, Charles, please.
All right. So I'm going to talk a little about web services, the work at W3C on making the web do things to make it cool, and some of the stuff we do with the semantic web, why we think that these things actually fit together. So, as a bit of a background, the web of yesterday, the web as it started out, was a collection of documents with some kind of connection between them. It involved people reading documents, people doing things, people interpreting what they saw and following links, using that information, doing the interacting. Web services, in one sense, is about computers interacting with objects on the web, computers doing things on the web, if you like. The work of web services in SOAP and with the sort of acronyms of today is part of a history of having a web that does things, of the CGI bin gateways, the little programs that processed forms and things are, if you like, the background to where a lot of web services stuff comes from. So that the idea of having a URI, an address that you can go to on the web where it does something with information or gives you not just a static page document, but the weather in Melbourne, is not actually a new idea. It didn't come about with SOAP. SOAP and these protocols are ways of doing that. The semantic web, on the other hand, is more related to the document view of the web, the information that is placed on the web, and it's related to the idea of allowing computers to read what's on the web. If you go and look at a document, you want to find the link that points to that document recommended over there, the semantic web is where you actually get that little bit of extra information to say, not just this document refers to that document, but this document refers to the document as a recommendation. Some document says, here is a good document. It says, there is a bad document. So the semantic web is allowing the tools that people like Dave are building to actually find out a good or a bad document, record that information, and use it to reduce the amount of work that we, the people, have to do in tracking through the web, in crawling the web. So, web services at W3C is a big activity. It's received a lot of attention in the last year or so, I suppose. The beginning of web services work was the XML protocols group, a group actually set up in 2000 to look at ways of passing objects around the web using XML to encode objects, to encode or to wrap messages that you wanted to pass back and forth between not just documents but between active services. A little step forward from a CGI bin which always had its own unique encoding pattern, was based on a particular kind of input that was not described anywhere except in the code that ran that thing, and you hoped that the form page or the page that provided the input actually gave the right kind of input. So that group has been working for about 2 years. Early this year, we launched the web services activity as an activity, and 2 more working groups were formed. One is the web services architecture group. That, I think, is kind of important. And I think that that's one of the reasons why people take work like this to W3C. That group's goal is to make sure that what we produce in the activity, the ways of describing services, the ways of putting them together, fits into the web architecture. Make sure that we have web services that actually work with the web. There's a description group, the web services description group. If you have a service out there, if there's some web server, something you can send some information to, it will process that information, it might give you something back. How do you know what that is? How do you know what kind of a service it is? So it's important to be able to find out what the different services are. A lot of work led to the web services stuff. There was a workshop held by W3C a couple of years ago. There were a lot of member submissions. I don't know if people know a lot about how W3C process works. It's a consortium. It has members who fund it, and they include software organizations, they include user groups, research groups, and so on. And those members, when they come up with an interesting idea, might make a submission. So we think this is an interesting thing to follow up for developing the technology of the web. As a different example, scalable vector graphics, a graphics standard that has been produced at W3C, was the result of different members saying, we have an idea for doing graphics on the web, for doing vector-based XML graphics. We had 4 or 5 different documents specifying an approach. We set up a working group who took all of those documents as input and said, okay, let's work out what we think we can do for the web, what works on the web. So web services work is based on a number of different submissions, specifications like SOAP at some stage in their lives have been submissions to W3C. Some of these are developed for a little while outside W3C. Somebody has a good idea in a lab somewhere in the world, writes a spec and says, hey, this really is a good idea, and sends it into, say, let's try and standardize this. Let's try and get some agreement on making this work. So, where are these things up to? There are two basic protocol pieces of work, a couple of specification things. SOAP 1.2 is the working draft that's being developed from, amongst other things, the SOAP submission. SOAP is a one-way protocol for passing objects. So it specifies a wrapper, an XML wrapper, that you can use to encode some information, which might be a piece of text, it might be a piece of executable code, it could be any kind of object, pretty much. You carry that over the web, you send it from one place to another, where presumably something will happen with it. So it might be that you send a SOAP encoded object because you're expecting a particular kind of response from wherever you send it to. A simple message response kind of model. It might be that you send a SOAP message which actually sends some other kind of message somewhere else. One of the demonstrations I don't have, but one of the guys I work with, the other Australian at W3C, has an SVG program. You get a nice little bank of light switches. When you hit a light switch, what happens is that actually wraps a SOAP message and sends it to his office. It turns the light on and off in his office. He can get away with turning the lights on and off in the office, and I can't, so I don't do that here. But that doesn't necessarily have a response to the individual. I could create some kind of object, send a message off that does something. There's nothing in the SOAP protocol, there's nothing in the services that requires that I ever get a message back saying that whatever I sent off arrived. It's possible for me to wrap up an object and say, go process this, send it to a service. The service processes that and does whatever it wants to do with it. WSDL, Web Services Description Language, is the other specification, if you like, describing web services. This is the, what does that web service do? What kind of information can I send to it? What kind of information can I ask it for? That, again, is based on a submission. I'll talk a little bit more about that. But part of the important work, what W3C sees as part of the important work in that is mapping that description language to RDF, being able to show that, in fact, you can represent the description of web services, which are, after all, resources on the web, in the resource description framework. And all of this work, these specifications are XML specifications. They're building on work that's been done. They're building on XML schemas. They're building on XML namespaces. These are fundamental web building blocks produced at W3C. By being part of W3C, one of the roles of the architecture group, who haven't published a specification, they've published a requirements draft. These are the things that the working group thinks are important requirements for web services specifications. Being in W3C, having those requirements, looking at the architecture means looking at existing tools like XML encryption, like digital signatures, the ability to use the XML world, the XML framework, and take advantage of the things it offers, like encryption, being able to sign the thing you send to a web service. Internationalization is something that's important to the Worldwide Web Consortium. The web services description language is not going to be very useful if we can't describe a web service in Arabic. So there are review groups at W3C that actually make sure these things can be used internationally. I work on accessibility. For a web service, there's not necessarily a human interface, so there's no direct accessibility impact. There are a lot of potential accessibility gains, but W3C, in some cases, can be seen as slowing down the work of producing a specification. It's not the organization which gets a good idea, puts a stamp on it and says W3C thinks this is a fantastic idea. Making sure it fits in the architecture is something that we think is pretty important. Making sure that you don't throw away all the HTTP machinery and decide to develop something new for doing what people are already doing seems to us kind of useful. The semantic web is a W3C activity, obviously. We have one. It's called the Semantic Web activity. It's more than just a W3C activity, but it is something that we're building on, particularly for describing services. So what do we do with the semantic web? Dave, Makx have both talked about aspects of it. It's about describing the web in terms of things on the web. So we describe objects in terms that are web-based and machine processable. RDF essentially lets us make statements about URIs, or about the thing addressed by a URI, and those statements can be placed on the web in the form of URIs so that we can keep on making statements about them. RDF schema, the Ontology language, what does L stand for officially?
Ontology web language or something?
It was a cool acronym, and then they have to figure out what words to use. But it means a language for describing ontologies, relating sets of statements in one vocabulary to sets of statements in another vocabulary. The framework underneath having descriptors and subdescriptors, extending information. So if you think of the Dublin core main elements and then qualifying those elements, providing further detail, RDF schema, OWL, and RDF are one model that you can use to actually be able to qualify those, to go into further and further and further detail about a particular object. And that turns out to be quite important. So the goal of the semantic web can be seen as making the web into a database that's queryable. Like you can go and query a SQL database today, being able to query the whole web. Because it's the web, it doesn't necessarily work perfectly as a database. There's more there than you want to get back from a query. But enabling that kind of thing, enabling searching of the whole web, of this massive collection of information, is one of the big things that we're trying to do. RDF and XML. Web services builds on XML. XML is the language of the future for everything, and everything shall be written in XML, except for a few things which aren't. RDF is written in XML most of the time. You can do things to RDF that you can do to other kinds of XML. That's quite handy because one of the things you can do with XML is mix different kinds of XML. So when you have RDF, it inherits that ability. You can mix statements, you can mix Dublin core information, URL information, different kinds of RDF information nice and easily. XML is fairly well known, it's fairly well understood. It's good for data with pre-specified semantics. It's good for information where you already know, or are fairly sure you know, the structure of the information. If you think about the SOAP work, the idea of being able to wrap up a block of information and send it as a message, there's not probably very much you're going to want to say about that block. Here is the message. That's a fairly simple structure. Writing that up, encoding it in XML seems like a pretty obvious and straightforward thing to be able to do. RDF brings a slightly different approach to recording the data, modeling the information. It's a graph rather than a tree. It doesn't assume a structure existing for the information you have. It allows you to examine a collection of data and to start adding semantics to the data. Start adding new ideas about how something relates. If you have a property existing, you want to say that the creator of this data is Dave Becket. There is RDF like the Dublin core. You can use the Dublin core creator property and say, well, the creator of this is Dave Becket. If you want to talk about some kind of aspect in an amazing level of detail and you've never thought about how to use this kind of statement before, for example, you might want to talk about the accessibility of a particular web page. If there isn't, and there isn't today, an accessibility property in Dublin core, you can create one in RDF and you can add that so that you can add new properties, you can merge those, you can make use of the ontology and schema frameworks to start relating properties to other properties. So where do they fit together? I think one of the most important places is in WSDL, Web Service Description Language. RDF describes things which have URIs, things which exist on the web. So from the perspective of RDF, a web service with a URI and a web document or some particular part of a document on the web are the same thing. It's just a framework for describing these things. Mapping the description language into RDF we think is important because if we just use an XML vocabulary, if we just assume that we can build one fixed catalogue now of all the types of services that people will use, or even if we say, well, we can build one catalogue now of all the kinds of services people will use until we get round to revising the catalogue, until we change the XML language in 2.5 years, which is a reasonable amount of time to renew a specification, then I think we're going to find that it won't work. One of the things that I got out of what Dave said is if you rely on people building structures and knowing in advance the structures, all the cool things, all the new things that turn up are the things that get dropped out of those structures, are the things that don't fit properly. So being able to apply the RDF extensibility the ability to add more and more detail allows us to do some neat things with services. Makes it fairly easy to say, this service converts XHTML in one particular form to XHTML in a very slightly different form. Its input and its output have the same syntax rules to within 99.9%. It might change one attribute name. This is not the kind of thing that people are going to build massive XML cataloging vocabularies to deal with. This is the kind of thing only 12 people will want to say. Describing services for chaining them together. It's cool that I can get a stock price for... I own no stocks. All right, I own no stocks, but I can get a stock price for Microsoft. And I can look at the stock price for Microsoft. This little web service will send that back to me. What am I going to do with that? Well, I can read the stock price and get excited about how much money I'm not making. What I actually want to do is have the computer do the work for me. Say, go and look at the stock price. And when the stock price goes below some magic number that a stockbroker tells me, go to another service and buy it. And don't ask me, don't make me do the putting together of these services. I find a document and I want to see this document on my mobile phone. The document happens to be in PDF format. I have a PDF to HTML converter. I have an XHTML to WML converter, for example. Can I describe the fact that this XHTML converter can actually process HTML as well, so that I can chain those two services together and get the document that I wanted onto my telephone by pushing it through the first service, by being able to find a description that's flexible enough to say HTML and XHTML are interoperable within these constraints. That's the kind of area where you want the level of detail that RDF can provide, I think. So I was going to talk for about 2 minutes about resource discovery. Two models of sharing information. And the use case that I had was ants and bees. We want food. We want something to eat as a community. We send out some scouts to come back and find the food. How do they tell us where it is? And it turns out that there are two kinds of approaches, and ants use one and bees use another. So bees, when they go and find the honey, they come back and they do a dance. They pass a message to the community. And as soon as they've passed it, it's gone. They've communicated that message, and then it's vanished. Ants don't. Ants actually leave a trail, so you can go and find the things that are... You can follow the trail where the ant went, and you can go back later and get the food. The other metaphor was changing the world. Some people want to change the world through protest songs, singing great music that will inspire people to change the world. Other people want to change the world by writing messages on the wall and inspiring everyone to do it that way. But it turns out that these things actually match, in some ways, the approaches of web services and RDF. If you think of a web service as a message that goes somewhere once, does something, and then vanishes, it's like the message passing of the bees, like email. You write an email, you send an email, it's gone. It doesn't necessarily change the observable state of the web. If you look at the world before the bees did their dance and the world after the bees did their dance, having done the dance, hasn't made a change to anything that you can necessarily see. The shared memory model, the ants model of leaving some information on the other hand, does change the world. You can see a trail. When you produce RDF and you stick it on the web, you can find a new document that didn't exist before. It's persistent. It's not a one-off message. What's the difference between those two things? Is it really true that all web services are one-off ephemeral messages being passed? Is it really true that all RDF is something that stays on the web? I think not. There are some web services where you will do this, you will use this service 2,000 times a day. If you think of Google as a web service, there's no reason why instead of giving it a URI with a question mark search equals something, you couldn't wrap up your search in a SOAP message, pass it to Google and say, give me your answers. And it will give you back the same kind of query. You should be able to replicate that process. You should be able to replicate that 1 million times. With Google, as the example, you can, because one of the ways that they refer to a search is as a URI, as a statement. Here is a document on the web. This address specifies asking Google for the following information. And you can then make RDF statements about that information, about that URI. Google results change. Why we use Google is because we think it's going to give us the best result at the moment, or why we use Lycos or Yahoo or whatever your favorite search system is. So when you start to talk about some of those things, you might actually want to have statements that are flexible, statements that change. You might want to produce RDF based on a web service. I want to find out some description about the documents Google refers to at the time I ask it. So those are going to be message-like objects, RDF kind of objects, but they're going to be produced by a web service. They will be somewhat ephemeral in value. So there, in summary, there's an approach that says web services can reproduce the entire web. You don't need anything else. You can throw away all the old architecture and just do web services. Well, in fact, you probably can. There's an approach that says you can throw away everything else and just do semantic web documents. And again, you probably can. It would take a little bit of stretching and a little bit of pushing to make one or the other of these be the way that you wanted to build the web. But it seems that if you actually put them together, each is best at some kinds of application. And that to get the full value out of the web, out of the interactive, machine-described, machine-understandable web, you want to use both of these things. You want to be able to actually make them work together and do the things that they are best at. Thank you very much.
Thank you, Charles. We are about to the end of the session, but still we have a time for one or two quick questions, if there are some questions. Okay, if not, due to the time, I would like to close this session, and please join me again in thanking all of our three speakers. And thank you very much for coming.